Hi guys, so today we're going to follow up a little bit on the derivative of function using the slope of a tangent line method. So one thing I wanted to note in the last example that I did, remember you've seen this um, function before. This is just the difference quotient. So it didn't pertain to the last problem because we ended up with a constant, but just remember the difference quotient, the limit as delta x approaches 0. In pre-cal we used h, but again, they can change the constants up a little bit. Sometimes you'll see x sub 1 as c. So it is the same format. So just wanted to note that first of all. And then for the derivative of a function, we're still going to go over the first example just because, or the first interpretation, just because now that you can't just see the slope because it's a linear function, I wanted to address the algebra there. But before we do, just kind of some things to note that you may see with derivative of a function. So let's say we're given a function f of x. To note that it's the derivative, you may see it as f prime of x. So this is the symbol for the derivative of a function. I also want to go over really quickly just what does the second interpretation mean, where x is an instantaneous rate of change over time of y with respect to x. You may see this in word problems, an instantaneous rate of change over time. So just kind of an example of that. Position is measured as distance, so we can call it meters, miles, anything with distance. So if I were to take the derivative of distance, it would give me velocity, which velocity is measured in distance over time, meters per second, miles per hour, things like that. Um, just to go a step further, if I were to take the derivative of velocity, that would give me acceleration. And acceleration is measured in distance over time squared. So meters over seconds squared, miles over hours squared. So notice that the instantaneous rate of change over time happens with each derivative. Meters per second squared. Okay, so back to the algebra of finding the derivative. Now, I'm going to start off just by noting the expression or the formula, sorry, that we're going to use. And the first term is going to take a sidebar because we have to find the expression there. So f of x plus delta x. Well, I know f of x equals x squared plus 1. So if I'm looking for f of x plus delta x, again, all I'm doing is replacing the x with x plus delta x. So instead of x squared, it's going to say, and in parentheses, x plus delta x squared and then plus 1. So all I'm doing is writing the same function, but I'm replacing the x with x plus delta x, always substitute in parentheses, because in this case, before I even put this back with the expression here, I'm going to expand this. X plus delta x squared. Anytime binomial has an exponent, take the literal definition of it, and you're going to FOIL x plus delta x. I'm going to take a sidebar here. Means you're going to multiply it by itself twice because it has an exponent of 2, x plus delta x here. So FOIL or distribute x times x is x squared. Outer x plus delta x is just x delta x. Inner x times delta x is again x delta x. And last, delta x times delta x gives me delta x squared, which I was thinking you wouldn't be able to see that either. Okay, so I'm going to put that on the end here, plus. Now notice that outer and inner are like terms, x delta x plus x delta x. This is like adding xy plus xy. We keep the like term, and we just add the coefficients in front of it, which is technically a 2, so 2xy. So this would give me x squared plus 2x delta x and then plus delta x squared. So all I did was combine the outer and the inner, the two in the middle. The first and last terms I just dropped down. They have no like terms. So I'm going to replace this with what I just did, which would give me x squared plus 2x delta x plus delta x squared. And then I'm going to drop down that plus one I haven't used at all. Okay, so it's expanded. Now it's ready to go back into the formula here. Okay, and then from here, minus f of x. So minus, and remember, we were given f of x, sidebar. Just make sure you substitute it in parentheses, x squared plus 1. Everything else I haven't used, bring it down. Okay, so from here, we're going to just distribute that negative. So then we can start simplifying the numerator and combining like terms. Out of room, so I'm going to go to the next. Difficulty in moving everything up. So let's start distributing this negative sign. So this would give me negative x squared minus 1. Now I know that I'm writing out every step, so keep in mind you don't have to. I'm just kind of making sure that every step is there so there's no confusion on where I got what. But it's not necessary for you guys to do either, unless you want to. Okay, so everything in yellow I'm bringing down. Only thing I did was distribute the negative to f of x. So from here, again, I'm just going to work on the numerator and just combine like terms where I can. I have x squared and I have negative x squared. That's gone. I have 1 and negative 1. That's also gone. So from here, I'm left with the limit as delta x approaches 0, 2x delta x plus delta x squared all over delta x. Now remember I told you in the last example, this is not a thing. You can't just cross out. If you can't factor it out, you can't divide it out. So factoring means if you have a plus or minus sign, the terms are separated, you should be able to factor in order to divide out. So notice that both of these have at least a delta x. They do have a GCF. If I factor that out of each one of these, I'm left with 2x plus delta x. So if I can factor it out, that's what I can divide out. And then bringing down what I have left, the limit as delta x approaches 0, 2x plus delta x. Remember that in pre-cal, if you took it with me, it's the limit as h approaches 0. We're doing the same thing here. They're just changing the variables to delta x, and you could still replace it with h if you wanted to, just like with time I let you guys replace that with x. It's fine. So in this case, after the algebra, simplifying the function using your algebra, factoring to divide out, you can apply direct substitution. Why couldn't we apply it before? Because if I directly replace delta x with 0, it would have given me a 0 denominator, and that won't work. So what we do is we make sure if direct substitution doesn't work, we try the algebra first, factor to divide out, and now I don't have that problem of a denominator of 0 because I don't even have a denominator. So if I replace delta x with 0, I'll get 2x plus 0, which is just 2x. And that is my derivative. All right, guys, I hope this helps.